I'm live. Look at that. I am live. Okay, so today, let's start right away with what is a radian. Okay, today is the 7th, 5/7/19. Okay, so let's start off real quick. What is a radian? Okay, we're going to write this down. What is a radian? Okay, a radian is simply an angle. It's an angle measure. So what is a radian? It's an angle. You have degrees, and now you have radians, okay? They're both going to be angles. One does things as far as a rotation, 360 degrees, right? So anytime we look at an angle in terms of degrees, it's like more of a opening. It's a rotation, right? But it doesn't do anything to describe the arc length, okay? But a radian is tied to the arc length. So a radian is an angle measure that is related to the arc length, okay? So I'm going to draw a real quick little picture right here. Theta, okay? So, if you have a radius of 1, am I going too fast? If you have just an arc length, okay, and if the radius is 1, then obviously this side here is 1. At about 57 degrees, so it's pretty close to about 57, I think it's 57.3, I think it's about 57.3 degrees, but remember, degrees are for dummies. About 57.3 degrees, right about there, the arc length is also 1. And that is what describes what a radian is. So what we do now is we can say that the angle, which is 1 radian, is also equal to the arc length, okay? So what we want to do is take a look at, on our unit circle, it's called the unit circle, and the word unit means 1, okay? Unit circle means 1, so the radius of this circle is 1, okay? And we want to describe the angles in here in terms of radians, okay? So if we want to make sure that the arc length is equal to the angle, okay? So let's think about this, okay? So if the radius is 1, we know that the circumference of a circle is equal to 2 pi r, okay? From geometry, that's the formula for circumference of a circle, okay? Got me so far? So if we just from geometry, so that means in this case, if the radius is 1, then the circumference of this circle is 2 pi, okay? So I know if I go all the way around, I'm going to go 2 pi. We're going to describe that angle as 2 pi because we want the circumference to equal the angle. Say it again. We want the circumference and the angle to be the same. So we're going to have an angle of 2 pi radians, not 360 degrees because that's for dummies, right? So my angle now is 2 pi radians. Okay, now let's keep simplifying this a little bit, okay? So we'll put a 2 pi right here, okay? We know that's 2 pi, right? Now, let's go half a circle. So half a circle, if it's 2 pi all the way around, then what we get is what we call pi. Put pi right there, and that's an angle. That's pi radians. In fact, if you take a look at the board, there's pi. And I've got the 180 right by it, because we'll put the dummy stuff up there too, okay? So pi or 180 degrees happens to be the same angle, but one describes the arc length because really, believe it or not, the length of this arc, if I were to take a piece of rope and lay it out and straighten it out, the length of this is 3.14 blah blah blah. It's not 180. Now think about this. This is not 180. That doesn't make any darn sense, does it? But the length of this arc, it really is 3.14 blah 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 blah. It's pi. So now the angle and the arc length have the same measure, okay? Okay, at 90 degrees, right here is 90 degrees. I know at 90 degrees, okay? Then at 90 degrees, I wouldn't have pi, but I have half that pi. So the radian measure is pi halves radius. That's my angle. My angle is pi halves, okay? 90 degrees is for dummies. That's a rotation. So it turns out the arc length is also pi halves, okay? So if I went pi halves for this angle, pi for this angle, then down here at 270 degrees, I would have pi halves, pi. I would have a 1.5 pi. We're going to call it 3 pi halves. Okay. So this is the angle. It's an angle. 3 pi halves is my angle. Corresponds to 270 degrees, but the cool part is the arc length is, if you use a calculator, whatever 3 pi halves is. We don't need to, but the exact length of this arc, because the radius is 1, right? The radius is equal to 1. If I went, clear that, if I went 3 times pi divided by 2, it's about 4.71 centimeters, inches, feet, or whatever. From here to here, that's the arc length. So the arc length and the angle are the same. They correspond. And then back to 3 pi, back to 2 pi, which is also my 360 degrees, right? So far, so good? Now, what we also want to do, we talked about yesterday about the special right triangles. We did the 30, 60, 90s yesterday. We did the 45, 45s, right? We did that as part of our activity yesterday. And we looked at the sine, cosine, and tangent of all those things, right? We want to put those special triangles in here also. Okay, so we're going to go ahead. First, I'm going to draw in a 45-degree angle. So I'm going to go ahead and take my ruler. I'm going to draw in a 45-degree angle. In fact, I'm going to draw it all the way across because I want the angle on the other side too. So I'm going to draw it all the way across like that, okay? So I drew it all the way through.
So just do the half?
Yeah, so halfway through, right, which is 45 degrees. So this is a 45-degree angle, right? But in terms of radians, okay, so it's 45 degrees, but degrees is for dummies, right? But in terms of radians, it's going to be pi force radians. That's the angle, pi force, okay? And of course, we're going to have another 45-degree angle over here. So I'm going to draw this one in. Am I going too fast? Am I doing okay? Okay, I'm going to draw this one in and let you catch up. Okay, that's another 45-degree angle. They don't have to be perfect. We just have to get the general. If you want to make it perfect, that's awesome. I'm just going to draw them in and make it close, okay? So that's going to be 135 degrees. 45, 90, 135. I'm just going by 45s. 45 degree, 45, 45, right? But in terms of radians, because that's what we need is really radians, it's really going to be 1/4, 2/4, 3 pi force. So as far as radians, it's 3 pi force radians, okay? That's my angle. Okay, it's also going to be the length of the arc. That's my angle. It's also the length of the arc, okay? So you can see that radians are super important. And when we start to look at things like sine waves, the length of the arc is super important. That's why we learn radians, because the applications are everywhere. Everywhere in science, okay? Now, let's keep going. So in degrees, for dummies, I've got my 0 degrees, 45, 90, 135, 180. And I'm going by 45s, right? So if I add 45 to this, I'm at 225 degrees, right? But in terms of radians, right? In terms of radians, I've got 1/4, 2/4, 3/4, 4/4. I'm going to have 5 pi force radians because I'm going by force. Okay, so I'm putting down my radian measures. Same angle, different name, right? The cool part about radians is the length of this arc from here to here really is whatever 5 pi force is. So it's got a connection to its arc length, okay? All right, now, 270, I've got this. Okay, so let's get my degrees. Almost there. I've got 45, 90, 135, 180, 225, 270, and then this one's going to be 25 more, which puts us at 45 more, puts me at 315 degrees for dummies, right? But in terms of radians, let's see. 1/4, 2/4, 3/4, 4/4, 5, 6, 7. This is 7 pi force radians. There's my angle. Okay, that's an angle of rotation. It's also the arc length, okay? Now yesterday, I had you guys do the special right triangles. I had you do these, right? So you did the 45, 45. We did all the 45s are in here. The 45-degree angles are in here, right? There's also the 60-degree angle. So I'm going to try and draw a 60. And it doesn't have to be perfect, but I'm going to estimate my 60. I'm going to be a little bit off. I'm not going to use a protractor. I'm just going to draw it, okay? I'm going to call this a 60-degree angle. So the rotation, if I were to put my protractor, that should be about 60 degrees, okay? Well, 60 degrees is a third of 180. 60 degrees is a third of 180, right? So it's going to be a third of pi, or we're going to call it radians. We're going to call it pi thirds, okay? Okay, now I've got another 60-degree angle on the other side. So I'll draw that in over here. All right, so I'll draw my other 60-degree angle here. And again, I'm not going to measure it. It's not going to be totally perfect, but it's going to be there, right? So I went 60, and another 60 puts me at 120 degrees, okay? So I went 6 degrees, another 60 puts me at 120 degrees. But in terms of radians, I've got a pi third. I'm going to have 2, 0, 1 third. I'm going to have 2 pi thirds is the radian measure of that angle. Okay, so we got two names for the same angle. You getting the idea? You've got two names for the same angle. You've got 120 degrees for dummies, or there's 2 pi thirds radius. Same name, same angle, different name. Okay. Okay. Then, okay, if I go 120, another 60 plus 180. So let me go ahead and draw in another 60-degree angle right about here. So I'm going to have my other, which I drew in. So this one right here, I drew in from that one to that one. So if I have then my 180 plus 60, 180 plus another 60 puts me at 240 degrees, right? Okay, so I already drew it all the way through. I drew this 60 all the way through. I already drew it. See, I already drew it through. See, I already drew it through. And so in terms of radians, here's how I can count 1 third, 2 thirds, 3 thirds. I'd have 4 pi thirds. 4 pi thirds radians. It's an angle, okay? It's just same angle, same spot, different name, okay? Okay, now I have this one right here, which I drew already. So I've got another 60 degrees. 60 puts me at 300 degrees, so this angle's at 300 degrees. In terms of radians, let's see, I count 1 third, 2 thirds, 3 thirds, 4 thirds. It puts me at 5 pi thirds radians, okay? And of course, I've got it up here, and I'll move this. We'll move this eventually so that we can see it, okay? But right now, I'm just going to put it up here, okay? Now, we've got all our 60 degrees. I've got 60. I got another 60-degree triangle. I've got another 60-degree triangle. I've got another 60. But we also have our 30-degree triangles, okay? So we're going to draw that one in also, okay? So now, if I'm going to draw my 30-degree, I'm going to take my ruler, and I'm going to draw right in here about a 30-degree angle. Okay, I'm going to draw it all the way across. Okay, so I'm going to draw in a 30-degree angle. Doesn't have to be perfect. If you're using a protractor, awesome. Mine are going to be a little bit more space. So I'm going to draw in all the way through my 30-degree angle. Okay, so here's my 30-degree angle right there. But degrees are for dummies, right? 30 degrees is a sixth, 1/6 of 180. 30 degrees is 1/6 of 180, right? So in terms of radians, 30 degrees is also going to be pi over 6, smart girl. Yeah, it actually makes sense, doesn't it? It's just, it's not hard. Okay, when you get to pre-calc or you get to college, they're going to expect you to have this memorized, okay? I won't. You don't have to have this memorized, okay? So then, let's see what we have. So, I'm going to have another 30 degrees right over here, okay? So I'd have another 30-degree angle here, so I'm going to draw this one in right here. So another 30 degrees right there. So let's see what I have. Okay, and again, my spacing's way off. Just forgive me because I'm not an artist. But so I've got my 30, 60, 90, 120. So this should be 150 degrees if I'm going by 30s, right? And then in terms of radians, I've got 1, 6, 2, 6, 3, 6, 4, 6. This is going to be a 5 pi 6th. And then I drew another 30-degree angle here when I drew it all the way through. Am I going too fast? Okay. So I really have another 30-degree angle I drew when I drew all the way across. So that's got to be, if I add 30, that's 210 degrees, right? But in terms of radians, I'm going to have 5, 6, 6, 6. I'm going to have 7 pi radians, okay? And then way over here, I've got another 30-degree angle. But that's going to be 330 because you got 360s, 30 less. Okay, 330. Does that make sense? 360 degrees here, but I'm 30 less. So this one's going to be 330. But in terms of radians, it's going to be 11 pi 6 radians. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11, 6. Okay. Now my circle isn't drawn very well, but it works. Okay. So what I want to do is this. If I need any kind of conversion, right? So for a moment, everybody have this?
Yeah.
If I asked you an easy question, okay, so I'd say, okay, my degree is 150 degrees. What's the radian? Easy. I can just use my circle, right? Go, okay, 150, 5 pi 6. So that's the equivalent, right? 5 pi 6, okay? No problem. Now, I don't want to put, I can't put everything on this thing, but what if I said I had, for instance, a 540 degree angle? Well, 540 degrees means I'm going to go around the circle more than once. Does that make sense? Okay, so let's see if I can do that. Okay, 540. Let's see. Let's minus 360 from that, okay? So 540, let's see, 540 minus 360. Hold on, 540 minus 360 is 180. So really, 540 is the same thing as 180 plus 360. Okay with that? Does that make sense if I add those together? Now, the reason I'm doing that is because let's take a journey. Let's take a trip. So I needed 540, right? So I'm going to go, ready? Watch. 360, and then I need 180 more, puts me right there, right? Okay, so what's the equivalent? Well, I went 2 pi, and then another pi. I really went 3 pi. I want to show you that again. Okay, I'm going to go all the way around the circle. There's 2 pi, and right here, so I went another pi. So the equivalent is going to be 3 pi radians, okay? Now, what about 75 degrees? Uh-oh. I don't want to put everything on the circle. I'd make the circle way too crowded. But maybe there's a formula for converting this. There is. So we want to make sure we have this formula on our notes. We're going to turn over our notes. And on the back, we're going to put a couple of formulas, okay? So we're going to change from degrees to radians, okay? Here's my formula, okay? We're going to have the radian will equal, okay? It's going to be the pi over 180 times my degree. So write that down. This is my conversion. Because if I had a 100-degree angle, what's it in terms of radians? Or, I mean, I can't put all of these on my circle. That'd be silly, right? So if I have a formula, it's an easy formula too, isn't it? So let's see how that works for 75. So for 75, let's see, my formula would be my radian is equal to my pi over 180 times my degree. That's my formula we just wrote down, right? So I'm going to put my 75 in for the degree, right? Sure. So, okay, my answer is going to be radians equal to pi over 180 times 75. Okay. Now, if I can keep these in terms of pi, they look nice because these are all in terms of pi, right? We could get an ugly decimal, but if I can keep it in terms of pi, so what I would do is rewrite this as 75 over 180 pi, and then I'm going to reduce that fraction. I just put that together as a fraction. You guys see that? 75 over 180. That's all I did. All I did is 75 over 180. Okay? That's all I did. And then if I reduce this, let's see if I reduce both by 5, or I'll show you a cool little trick on my calculator. Want to see a cool little trick on your calculator? This is awesome. You'll love it. 75 divided by 180. Go to math. Fraction. Boom. Reduces it for me. 5/12. Let me show you that again. Want to see that one again? So, 75 degrees is 5 pi 12ths. Got to keep the pi there, right? So I just reduced. All I did is reduced that fraction. Reduce my fraction. 75 degrees is 5 pi 12ths. So if I had my 75 degrees, which is right around here, then I know the length of the arc is 5 pi 12ths, right? So it's an angle. Okay, now, what about going the other way, okay? What if I had, for instance, example, what if I had a, let's go 5 pi 8 radians. And that's somewhere on the circle, right? Somewhere on the circle, right? Some kind of degree, and I want to convert this to degrees. All right, well, of course, we have a formula for that. So it's just the opposite formula. So if we want to then also go from radians to degrees, and it's on the back of my circle, right?
So d equals 180 over 5 by
You're
12?
so smart. How'd you get so smart? Yes, smart girl. So D is equal to 180 over pi times my R. Totally right, Daisy. It makes sense. It's just the opposite, right? And that's our two formulas. So then go ahead and write that down. And let's use that formula to do the next one. Okay, so if I go, okay, here we go. I'm going to go 5 pi. So I'm going to use my formulas. My D equals 180 over pi times my R, right? And then what I'm going to do is put my radian in. So I'm going to go degree is equal to 180 over pi times my 5 pi over 8. Because I'm just going to put my 5 pi 8s in for the radians, right? It's going to convert it for me. Yes.
Could you put the other one back?
Which one? The formula? Yeah, you guys didn't get that written down yet? My bad. Okay, go ahead and write that down. There's your formula right there, okay? Those are two super important formulas. You guys agree? But they're easy. They're little itty-bitty formulas. They're not difficult, but they do make the conversion from degrees to radians, okay? Tell me when you got it. Okay, so then all I did on this problem is I put my 5 pi 8s right there. Okay, so my formula, put my 5 pi 8s there. Okay, so I'm almost done. What do you see something simple, I'm hoping? Do you see something simple that I can do right here?
You can cancel out the pi.
Thank you. So cancel out the pi's, right? And so when I'm using my calculator, I'm just going to go, what is 180? What is 180 times 5 divided by 8? What is that answer? 112.5 degrees. Okay, 112, so I get an answer of about 112.5 degrees. Okay? So, double check everything. I think I gotcha. I think we have everything we need, okay? So, thumbs up. Okay? Let me go ahead, before I finish, radians are angles. Okay, radians are angles, but better than that, they also correspond to the arc length. That's why they're so important, okay?